So hey guys, welcome again to my vlog. So this is the chapter 10, the application layer. So let's proceed to the discussion. Applications such as a web browser, online gaming, chatting with the emailing friend enable us to send and receive data with relative ease. Typically, we can access the use of this application without knowing how they work. However, for network professional, it is important to know how an application is able to format, transmit, and interpret messages that are sent and received across the network. Visualizing the mechanism that enable communication across the network is made easier if we use the layered framework of the OSI model. So, LLC sublayer. The Ethernet LLC sublayer handles that communication between the upper layer and the lower layers. This is typically between the networking software and the device hardware. The LLC sublayer takes the network protocol data, which is typically an IPv4 packets, and adds control information to help deliver the packet to the destination node. The LLC is used to communicate with the upper layers of the application and the transition and the packet to the layer for delivery. MAC sublayer. MAC constitutes the lower sublayer of the data link layer. MAC is implemented by hardware, typically in the computer NIC. The specific are listed in the IEEE 802.3 standards. Figure 2. Least common IEEE Ethernet standards. Data encapsulation. The data encapsulation process includes frame assembly before transmission and frame disassembly upon reception of a frame. In forming the frame, the MAC layer adds a header and trailer to the network layer. PDU data encapsulation provides three primary functions. Frame delimiting. The framing process provides important delimiters that are used to identify a group of bits that make a frame. This delimiting bits provide synchronization between the transmitted and receiving nodes. Media access control. The second is responsibility of the MAC sublayer is media access control. Media access control is responsible for the placement of frames on the media and the removal of frame from the media. As its name implies, its control access to the media. This sublayer communicates directly with the physical layer. Ethernet frame fields. The minimum Ethernet frame size is the 64 bytes of the maximum is 1518 bytes. This includes all bytes from the destination MAC address field through the frame check sequence FCS field. The preamble field is not included when describing the size of a frame. MAC address and hexadecimal. An Ethernet MAC address is a 48-bit binary value expressed as 12 hexadecimal digit, 4 bits per hexadecimal digit. Just a decimal is a base 10 number system. Hexadecimal is a base 16 system. The base 16 number system uses the number of 0 to 9 and the letters is A to F. Figure 1 shows the equivalent decimal and hexadecimal values from binary 40 to 41. It is easier to express a values as a single hexadecimal digit than a 4 binary bits. Given the 8 bits, 1 byte is common binary grouping binary. 80 and to 81 can be represented to hexadecimal as arranged 00 to FF. As shown in figure 2, leading zeros are always displayed to complete the 8 bits representation. For example, the binary values 0000 and 1010 is shown in hexadecimal as OA. Layer to the network layer. PDU data encapsulation provides three primary functions. Frame delimiting. The framing process provides important delimiters that are used to identify a group of bits that make a frame. This delimiting bits provide synchronization between the transmitted and receiving nodes. Media access control. The second is responsibility of the MAC sublayer is media access control. Media access control is responsible for the placement of frames on the media and the removal of frame from the media. As its name implies, its control access to the media. This sublayer communicates directly with the physical layer. Ethernet frame fields. The minimum Ethernet frame size is the 64 bytes of the maximum is 1518 bytes. This includes all bytes from the destination MAC address field through the frame check sequence FCS field. The preamble field is not included when describing the size of a frame. MAC address and hexadecimal. An Ethernet MAC address is a 48-bit binary value expressed as 12 hexadecimal digit, 4 bits per hexadecimal digit. Just a decimal is a base 10 number system. Hexadecimal is a base 16 system. The base 16 number system uses the number of 0 to 9 and the letters is A to F. Figure 1 shows the equivalent decimal and hexadecimal values from binary 40 to 41. It is easier to express a values as a single hexadecimal digit than a 4 binary bits. Given the 8 bits, 1 byte is common binary grouping binary. 80 and to 81 can be represented to hexadecimal as a range 00 to FF. As shown in figure 2, leading zeros are always displayed to complete the 8 bits representation. For example, the binary values 0000 and 1010 is shown in hexadecimal as OA. Note, it is important to distinguish hexadecimal values from hexadecimal value regarding the characters 0 to 9 as shown in the figure. Representing hexadecimal values. Hexadecimal is usually represented in text by the value preceded by OX or a subscript. Less commonly, it may be followed by an H, for example, 73H. However, because subscript text is not recognized in command line or programming environments, the technical representation of hexadecimal is preceded with OX. Therefore, the examples above would be shown as OX, OA, and OX73 respectively. Hexadecimal is used to represent Ethernet MAC address and IP version addresses. So, hexadecimal conversions. Number conversions between decimal and hexadecimal values are straightforward, but quickly dividing or multiplying by 16 is not always convenient. If such conversions are required, it is usually easier to convert the decimal or hexadecimal values to binary, and then to convert the binary value to either decimal or hexadecimal as appropriate. Filtering frames. As a switch receives frame from different device, it is able to populate its MAC address table by examining the source MAC address of every frame. When the switch MAC address table contains the destination MAC address, it is able to filter the frame and forward out a single port. Auto MDIX. When the Auto MDIX feature is enabled, the switch detects the type of cable attached to the port and configure the interfaces accordingly. Therefore, you can use either a crossover or a straight-through cable for connection to a copper. 10-100-1000 port on the switch regardless of the type of device on the other end and the connection. So, the application layer. The application layer is closer to the end user. As shown in the figure, it is the layer that provides the interface between the application used to communicate and the underlying network over which messages are transmitted. Application layer protocols are used to exchange data between programs running on the source and destination host. There are many application layer protocols, and new protocols are always being developed. Some of the most widely known application layer protocols include Hypertext Transfer Protocol or HTTP File Transfer Protocol or FTP Trivial File Transfer Protocol, TFTP Internet Message Access Protocol, IMAP, and Domain Name System. Presentation and Session Layer. The presentation layer must three primary functions: formatting or presenting data at the source device into a compatible form of received by the destination device, compressing device in a way that can be decompressed by the destination device, encrypting data for transmission, and decrypting data upon receipt. So that's all for the chapter 10. I hope you learned something from my blog. So thank you and goodbye. Thank you for watching and listening. Don't forget to subscribe.